If you like our video, click the like button. Click the subscribe button to receive updates on our new video. Don't forget to share our video too.
Okay, let us revise the logical connectives in brief. Now there are basically 5 logical connectives. Okay, you have not, and, or, if then, if and only if. The not is also called as the unary connective, whereas and, or, if then, if and only if, these 4 are termed as binary connectives. Because not does not actually connect 2 statements, right? But it has an impact on the statement. So not comes under unary, and, or, if then, if and only if, these 4 come under binary. Now let's see the symbol. For not, the symbolic form is this way. There's a similar sign, okay, that is not. Sometimes they also use this symbol. Okay, so that is also a symbol for not. Then next is and is like an A. Okay, yeah, this up arrow. Then or would be its opposite, that is the down arrow this way. Then if then is the arrow pointing right. Okay, now sometimes we also use this double line over here. Okay, so this is also for if then. Next is if and only if, so it's both ways, yes, left and right. Similarly, you could use a double line and the arrow on the left and arrow on the right, both ways. So these are the symbols for the logical connectives. Now the rules which we follow for these logical connectives are, now negate of, okay, when you take not on the true value, it results in false. Then when you take or apply not on a false statement, it results in true. So negation of T is false, negation of false is true. Okay. And the rule for and is, if the first statement is true and the second statement is true, then the result is true. For or, if the first statement is false or the second statement is also false, then the result is false. For if then, here the rule is, the if part is true, the then part is false. Remember, if true, then false. So the result is false. And for if and only if both the truth values are the same, that is true true or both false false, okay, then the result is true. So these are the rules which we follow for the logical connectives. Now the use of not results in a compound statement, and that compound statement we say it's the negation. Okay, so the resulting compound statement is negation. And is called, the statement containing and is called conjunction. For or, we call it as disjunction. Okay, so you have disjunction for or. If then, it's called conditional. Okay, now it is also called as implication, so we just call it as conditional or implication. And if and only if, now it's two-way condition, so it is bi-conditional, or it is also called double implication. Okay, so remember, for if then it's conditional, or I'll just put it down, it's also called implication. Okay, so you have implication. And this one, biconditional, or we also call it as double implication. Okay, so these are the various logical connectors, right? So not, and, or, if then, if and only if. Easy, aren't they? Okay, we now talk about the words or phrases which could replace the logical connectives. Now not is many a times replaced by the phrase it is not true that, or it is false that, or it is not the case that. So all these are actually replacements for not. Likewise, but, yet, though, still, moreover, all these words are replacements for and. Likewise, either or, this is a replacement for or. Now the various forms for an if-then statement. Suppose you have a statement if P then Q. Now this could be rewritten in different forms. So if P then Q could be written as P implies Q, or P is sufficient for Q, or Q is necessary for P, or P only if Q. Next is Q if P, Q when P, Q follows from P, and lastly sufficient condition for Q is P. So these are the various forms of an if-then statement. Okay, now we move to the various forms of an if and only if statement. So suppose you have a statement like P if and only if Q. Now you could write it in different formats. The first one is you could write it as Q if and only if P, or P is necessary and sufficient for Q, or you could also put it as Q is necessary and sufficient for P, or lastly P implies Q and Q implies P. Like it, share it, and subscribe our channel for more such interesting videos in future. Thank you.